Hi everybody. We're ready for day 2 of solving quadratic equations by factoring. Yesterday you did a lesson on factoring, and just a reminder, first you have to make sure that the quadratic equation is equal to 0, like we see in example 1. We're going to factor the left side, and then we're going to take our factors, we're going to set each one of those equal to 0, and then solve for x. Okay, just let me back up just a little bit here, and I just want to tell you why we're doing that. We're using what's called a zero product property, which we may have gone over earlier in the year. But just to give you a reminder, zero product property says that if you have two numbers, for example, if you have x and you have y, and you multiply those two and you get a 0, one of those numbers has to be 0, or they're both 0. So x could equal 0, or y could equal 0, or they could both equal 0. And that's what we're doing when we set these equal to 0. Okay, so today, as you can see, we are starting out with equations that do not have an a that's equal to 1. Okay, so the first thing we always want to do is we want to look for a greatest common factor. Okay, if we can divide that out, it makes things much simpler. So we always start with that no matter what. And it looks like we can divide a 3 out of this equation. And so we're going to end up with x squared plus 3x minus 4 equals 0. And we're ready to factor. And so we're looking for two numbers that multiply to -4, add to 3. That should probably be, we could use x plus 4 and x minus 1. Okay. All right, so there are two factors. And so let's break those apart. X plus 4 equals 0. X minus 1 equals 0. And we solve for that, subtract a 4 here. One of our solutions is -4. Add 1 to both sides here. Our other solution is +1. So these are the two solutions that you could substitute in for x, and they would equal 0. Okay, moving on to number 2. Again, we're going to look for a greatest common factor. That's where we usually start. This one looks like it has a greatest common factor of 5. So let's divide that out, and we will have x squared minus 4x minus 12 equals 0. All right, and we're going to factor that. And so we could probably, let's see, 1 and 12, no, 2 and 6. 2 and 6 sounds promising. So x minus 6 and x plus 2 multiplies to -12 and adds to -4, so that works out great. And let's set each one of those, equal to 0. So x minus 6 equals 0, x plus 2 equals 0, and if we add 6 to both sides here, one of our solutions will be +6. Subtract 2 from both sides here, our other solution will be a -2. So we could substitute in a 6 for x, and we would get a 0, or we could substitute in a -2 for x, and we would get a 0. Two solutions. Okay, as we move on to number 3, it's set equal to 0. That's good. But I don't see a greatest common factor. And so that leaves us with moving back to grouping. Okay, we're going to solve by grouping. Okay, and remember when we did that, we looked at a times c. So a times c equals -10 in this case. And we looked at b, and b is 3. Okay, and so we're looking for two numbers that multiply to -10 but add to 3. So let's see. We start out with this. We keep the first term, 2x squared, and we're going to use a +5 and a -2. Multiply to -10, add to +3. And remember, we keep the third term, the constant, and now we can group. We have 4 terms. We can group those. Okay, divide out the common factor in the first set. That would be an x. That leaves us with 2x plus 5. And then over here, it looks like we can divide out, looks like a 1, and we want to take out a -1 to get rid of that negative there. So divide out a -1, that would give us 2x. Divide by -1 here, it's a positive 5. And there we have our factors, x minus 1 and 2x plus 5. And again, we're going to set each one of those equal to 0 and then solve for x. And I've run out of space, so I'm going to go over here. So x equals, I add 1 to both sides here, x equals a positive 1. Subtract 5, divide by that 2, I get a -5/2. And so those are the two solutions I could substitute in for x and get 0. Okay, one more like that. It's equal to 0. Looking for a greatest common factor? No. And it's in standard form. So let's look at AC. AC equals 40. B equals -22. So we're looking for two numbers that multiply to 40 and add to -22. I'm thinking 2 and 20 sound good. And so let's start with that. Start with the 8x squared. And we're going to need a minus 2x and a minus 20x so that they add to -22 and multiply to a positive 40. Bring down the 5 plus 5. And we're ready to factor. We have 4 terms. So we're going to divide out 2x here. It's a common factor. That leaves us with 4x minus 1. And it looks like we're going to divide out a -5 here. So -5. That leaves us here with a positive 4x. And divide these two, you get -1. All right, so here are our two factors, 2x minus 5 and the 4x minus 1. We'll set each one of those equal to 0. 2x minus 5 equals 0. 4x minus 1 equals 0. And our two solutions will be x equals, add 5, divide by 2, that would be 5/2. Add 1 to both sides, divide by 4, and 1/4 is our other solution. Okay, let's go to the back side now, and let's take a look at number 9. We'll take a look at numbers 9 and 10 before we leave. Okay, so if we start back at the beginning, this is not equal to 0, so we need to add 2 to both sides so that we have 3x squared plus 7x plus 2 equals 0. So now we are equal to 0. We're in standard form, and I do not see a greatest common factor. So let's start out with that AC again. That would be a 6. Our B is 7. So it's looking like a 1 and a 6 would be good. 1 times 6, 1 is 6, and 1 plus 6 is 7. So we'll go to 3x squared plus 1x plus 6x, and bring down that plus 2 equals 0. Okay, factor, because we have 4 terms. We can divide out an x here. So 3x plus 1. Over here we can divide out a 2, positive 2. Divide, we get 3x. Divide, we get 1. Okay, and there are our two factors for this equation are x plus 2 and 3x plus 1. Set each one of those equal to 0. And our solutions will be, subtract 2 from both sides, we get a -2. Subtract 1, divide by 3, we get a -1/3 for our solution there. Okay, so just a little bit longer. We have to make sure that that it's equal to 0. And so again, we need to subtract this term, so it moves over here. And we have 8x squared minus 10x plus 3 equals 0. And that way we are equal to 0. We are now in standard form with our x squared, x, and our constant, and no greatest common factor. So let's look at AC, which equals 24, and B equals negative 10. So two numbers that multiply to 24 and add to negative 10. How about 2 and 12? Let's try 2 and 12. 8x squared, and I think we're going to need a minus 2x and a minus 12x. So they multiply to positive 24, and they do not add to a negative 10. So are there other factors that we could use? Let's see. 2 and 12, 3 and 8, 4 and 6, 4 and 6, 4 and 6, negative 4, negative 6. Sometimes you have to look at more possibilities. So they multiply to positive 24 and they add to negative 10. Great. Okay, then we're going to pull down our plus 3 equals 0. We're ready to factor because we have the 4 terms. Let's divide a 4x out of here. That leaves us with 2x and a minus 1. And over here, we're going to divide out a negative 3. So that leaves us with a positive 2x minus 1. That worked out nicely. And our two factors then for this equation are 4x minus 3 and 2x minus 1. Set each one equal to 0. And we get x equals, let's see, add 3, divide by 4. That leaves us with 3/4. Add 1, divide by 2. That leaves us with 1/2. And those are the two solutions that solve this equation. All right, real briefly, let me talk about number 12. You want to make sure that you get it to equal 0. So don't forget you're going to need to subtract the x squared from both sides. That leaves you with a 4x squared. And you need to subtract 2 from both sides. That leaves you with 4x squared plus 7x minus 2 equals 0. So be careful moving those around. All right, and that's how you find solutions to these quadratic equations using the grouping method.